All right, here we go. So, section 3.3 is all about how to prove lines are parallel. So, we already have if-then statements about these angle relationships on our purple sheet that we'll be able to use, right, for your quiz. So now we're just going to be doing the converse of it. So, abbreviate however you want to write this. If you want to write it full words, write it full words, do whatever you want. So the converse of our corresponding angles postulate says the following. If corresponding angles are congruent, then the lines are parallel. If it were me, I would just write if core angles congruent, then 11.
You said if core, then 11 lines.
Yes.
Ruh-roh, Roby.
So the only thing that's going to change on the algebra problems are going to be the directions. Your directions to your homework said find the value of x given these parallel lines. So now what the directions are going to say for this problem is find the value of x that makes the lines parallel. But the process is going to be exactly the same. The only thing that's going to change, so if it's a 4-point problem, you're going to get 2 points for getting that x correct, and then you're going to get 2 points for writing the correct if-then statement. So you got to make sure if it's the converse or the original, and which one it needs to be. So find the value of x that makes m parallel to n. Do we have corresponding angles? So what the converse says is if these are congruent, then my lines will be parallel. And when things are congruent, that means we set them equal. So 3x plus 5 equals 65. Subtraction property, subtract your 5 from both sides, gets you 3x equals 60.
3x 60 divided by 3x would be...
X is equal to 20.
Yes.
So now our if-then statement, this were the quiz, would say if corresponding angles congruent, then parallel lines. Okay, so you need to be able to solve it correctly, but then you also need to be able to justify why you were able to do that. So if x is 20, that makes the lines parallel. If x was 10, this angle would be how many degrees? If x was 10, this would be 35 degrees. And can you envision 35 would be more of an acute angle than 65? So then eventually it would come down and intersect and not be parallel anymore. So the only way to really make sure that it's going to be parallel is if that angle is the same as this 65 down here. Okay? All right, so let's do the converse of the other three. So again, abbreviate as you want.
Yep.
If alternate interior angles are congruent, so if you want to abbreviate if alt int angles congruent, then 11?
And 11 lines, yeah.
Then 11 lines. Then parallel lines? I'm sure you can start writing down the other ones too while you're going. You want to get ahead of the game. Huh?
Are you recording this right now?
Yeah.
Oh, she is. So
Huh?
she's probably just going to mute all of us.
They can. Yes, that is Joe talking.
Don't listen to Roby.
This is going to be all the fun. So you're only recording
And our voices.
Yeah. So she can't hear him?
So you're going to like edit this out of there? Or what?
No, I just throw it in there.
Through that.
All right, alternate exterior. And if I hold it like this, it'll record your movements too. No, it doesn't. All right, alternate exterior.
Okay.
What What is so funny? Like,
She has a face
We're on
scan
YouTube,
videos, dude.
Christian.
Yeah, we're on YouTube right now.
If alternate exterior angles are congruent, then lines are parallel.
if
Then 11 lines.
I don't get it. We've written this down like 5 times.
Yeah, this is just the converse.
this is we're doing it the 6th time, is it?
Yeah. Last week it was if parallel lines, then
then
alternate interior.
gotcha.
And then what would be the converse for consecutive? If consecutive interior angles are
Congruent, or,
supplementary, then parallel lines.
You need a couple more. Make sure you're awake.
Okay, so if consecutive interior angles are supplementary, then lines are parallel.
Oh,
I will do it if you tell me to. I know.
if
It doesn't work for you.
It's just a man with a Nissan Mary. I threw that out, actually.
Okay, focus on what you're doing, please. Yeah, I'm gonna come stand right next to you.
Okay, awesome.
All right, so here we go. Are we good?
Yes.
Okay, so I know this is a little confusing because there's that little bar line up top. So you see where it has the line? So let's write down our theorem on that line. What angle relationship do we have? Consecutive. So if cons int angles sup, then parallel lines.
If concept angles
Then sup.
up, out,
S up.
Then parallel. So,
Then 11.
and this is a common mistake that students will do. Now pay attention, so this is not you. Students will write this correctly, and then they'll set these things equal to each other. Why does that not make sense?
Because they're supplementary.
Because you said here that they're supplementary, but then you didn't do supplementary work. You did congruent work. So that means I'm going to add these together. So 2x plus x equals 180. 3x equals 180. So x is equal to, what is that? 60?
Yes. No.
We just solved for x. So make sure your algebra makes sense to what you claimed was going to be happening.
So basically, we just did 3 steps in one.
Huh?
We did 3 steps.
How do you,
Just using that, or we just did the first step.
The first step, by knowing that we had to add them and equal them to 180, because that's what supplementary means, right? So don't set them equal when you said they're supplementary.
Yeah.
All right, the next one to the right of that, what angle relationship do we have here? Good. So if alt int angles congruent, then parallel. That gets you 2 out of your 4 points on the quiz. So because I said they're congruent, don't add them and equal them to 180. Set them equal to each other. So 2x plus 20 equals 3x. Subtracting 2x from both sides gets you 20 equals x. Now you just got the other 2 points. Okay? All right, so are we good with these type of problems?
No.
So now really quickly listen to this, because some of you guys are going to screw this up. On the quiz, there's going to be 4 problems that are going to look like this. 2 of them will have directions that say find the value of x that makes them parallel, which would then be this if-then statement, where your conclusion is that they're parallel lines. 2 of them will say find x given the lines that are parallel. Then you should have the original if-then statements where it says if parallel, then alternate interior angles are congruent. So make sure you pay attention to that. Don't lose silly points because you weren't paying attention. So it should be easy. So if you're concluding that you have parallel lines, put it in your conclusion. If you're given parallel lines, put it in your hypothesis. Make sure you pay attention to that, and we'll make sure we work through that stuff tomorrow. Okay? All right, so let's go on to the back and do some proofs. So the nice thing about these proofs is that they're pretty quick. Not a whole lot of steps. But you just need to make sure that you can see what the heck's happening. So, line 1, always you're given. Now, look at angle 2 and angle 3 up there. They are vertical. Are vertical angles congruent?
Yes.
Yes. So now what will be my if-then statement for line 2?
If vertical, then 11. No, if vertical angles, then congruent.
Good. If vertical angles, then congruent.
Why? I don't understand. I genuinely don't understand.
Vertical angles are congruent. These are vertical.
Okay, never mind.
All right, so now look at angle 1's right here and angles 2's right there. Is that any special angle pair relationship? Not corresponding. It was a trick question. They're not. They're not. So, guys, quiet please. Because they're nothing special, your brain should be thinking, I wonder if this is a transitive property. Is it?
No.
Here I have 1 congruent to 3.
It is.
Here we said 2 is congruent to 3.
Yes, it is.
Why would 1 be congruent to 2? Because of the transitive property. So transitive property. All right, now look at 1 and 4. There's 1, there's 4. Are they any special angle pair relationships? Alt interior. Now, remember, we're trying to get to parallel lines, right? So if my alternate interior angles are congruent, would my lines then be parallel?
Yes.
They would be, but that's going to be my statement for line 5. If alt interior angles congruent, then parallel. I did. Because the purpose is, most of you guys are going to put this in line 4, and that's not correct. Because remember, in your if-then statement, your conclusion should directly match up with what we said over here. And over here I'm saying I have parallel lines, which means my conclusion needs to be parallel lines. Well, why are they parallel lines? Because alternate interior angles are congruent. So before we get to that, we got a whole bunch of things being congruent. Up here I had 2 congruent to 4. Here I had 1 congruent to 2. So what tells me then 1's congruent to 4? Another transitive property.
Another 11. Twice?
Yep,
Yeah.
I'm just doing those ditto marks.
that's fine. You can do ditto marks.
What's the ditto mark again? It's like a
Ditto, 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 ditto.
Can you say
No more ditto marks.
the little quotation marks?
No, you can do dittos.
No. Really?
Okay?
Say it like, same thing.
Or just rewrite trans property twice.
Yes.
All right, proof number 2. I like the givens that some people already started.
What's the given?
Alicia.
Now, look at what's given to you.
1 plus 1.
Here you have one set of parallel lines already being given to you. And if you guys remember on Friday, that meant I needed to have how many lines over here saying if parallel? 1. If I got one parallel line here, then I'm going to have something here talking about if parallel lines. So, look at 1 and 2. What angle relationship do we have? Corresponding. If C and D are parallel to each other, would 1 and 2 be congruent? Yes. So if parallel, then corresponding angles congruent.
Ruined.
What do you think line 3 is going to be?
Transitive.
It is transitive.
And 4.
If you look at line 4, what gives us parallel lines? Well, congruent corresponding angles gives us parallel lines. Congruent alternate interior angles give us parallel lines. Congruent alternate exterior give us parallel lines. So what is 1 and 3 up in that diagram?
Alternate interior.
Alternate interior. Colby?
What is 2? What's that?
If parallel, then corresponding angles congruent.
If parallel, then corresponding are.
Are congruent.
Are congruent. So here we're going to say if alt int angles congruent, then parallel. So these are a little bit more confusing because you kind of have to think about this in reverse. It was a little bit easier on 3-2 because we were going from here to here. So don't put this if-then statement where line 3 is, because we're not concluding parallel lines right here. Right here I'm just talking about congruent angles. So why are they congruent? Because of the transitive property. All right, let's do the last one.
Would they just be alternate interior?
For which ones?
1 and 3.
Yeah. But we don't know they're congruent yet, but because of the transitive property, because 2 is congruent to 3, 1 is congruent to 2, take out the 2's, 1's congruent to 3. So then because they're congruent and they're alternate interior, that makes you have parallel lines. Christian? Yeah. All right, line 1, we've got our given. So, 1 and 2 are congruent. Why would those lines then be parallel?
Because they're both going.
What angle relationship is 1 and 2?
There's straight lines in the supplement. Corresponding.
They are alternate
Corresponding.
interior.
So if corresponding angles congruent, then parallel. Because, right, my conclusion here is talking about parallel lines. What's written over here? Parallel lines are supplementary. Exactly. So now because I have parallel lines, why would 5 and 7 be supplementary? What angle pair relationship?
Oh, they're consecutive interior.
Yep. So law of syllogism. If parallel, then consecutive interior angles are supplementary. Okay?
No.